Hello, everybody, once again. It's Mr. Grosso. The next topic that we're going to take a look at is volume. So, area was the amount of space inside of a two-dimensional figure. Volume is the amount of space inside of a three-dimensional figure. So, same idea, just on a bigger, more number-involved scale. So, we could take a look at like all of the basic three-dimensional shapes like cubes and rectangular prisms and cylinders and all that stuff. But we're really only going to break it down into three shapes essentially. We're going to look at pyramids, we're going to look at cones, and we're going to look at spheres. Spheres we're going to handle, the next time we meet. But for this one, we're going to take a look at pyramids and cones. So all the pyramids are, as well as the cones, is you're going to have a two-dimensional figure on the bottom, and every corner on that two-dimensional figure is going to come up to a point. That's the only thing that really makes it a pyramid. And a cone is the essential same thing, but instead of like a square or a rectangle or a triangle or an octagon or whatever the bottom shape is, it's a circle. So whenever things have circular things to them or parts to them, they always get treated a little bit different because they have to involve pi. So the kind of pyramids that we're going to take a look at, we're only going to take a look at pyramids that have a square base or a rectangular base. We're not going to get too crazy into it. So figuring out the volumes for these, they have a formula. So all you got to do, the formula, the nice thing about formulas is they never change. They are always the same thing. The numbers that you're going to plug into them can change, but the setup of the formula never changes. So here's the volume formula for a pyramid. It's going to be length times width times height. So let's take a look at this. So this is the setup that you guys are going to see, and this is the setup that you guys are going to have to plug the numbers into when you guys are practicing. So the length could be this 5 right here. All right, so you're going to plug that in there, and the width could be this 5 right here. All the length and width are the numbers that are going to make up your base, like bottom shape, two-dimensional shape. So length and width are going to be those 5s because it's a square base. All of those sides are 5. If this length, or I'm sorry, if this measurement of this side is 5, this measurement over here of that side that's going the same direction is also 5. Same thing with this 5, and over here that would be 5. And then the height is just how tall the pyramid actually is, which will be indicated by like this little blue line for, should be all the triangular prisms. So for this particular example, it's 7, so you're going to plug 7 in there. When you multiply these things out, 5 times 5 times 7, all right, don't forget this last little step of dividing it by 3. All right, and because we're dividing by 3, a majority of the times that's going to lead to a repeating decimal, unfortunately. So please feel free to use calculators for all of the volume problems. The last thing that Ms. Coleman and I want to do is burn you guys out with the long division of repeating decimal problems. That's not what we're going for. So when you multiply all three of those numbers out and divide by 3, this is what you're going to get. You're going to get 58.33333333, and it just keeps on going. So what we're going to ask you guys to do is to round your answer to the nearest tenth. All right, so the tenth is this bolded number right here. It's the very first number after the decimal point. But in order to round to that place, you have to look at the one next to it on the right, the hundredths place, to see if you're going to round up to the next highest number, or if it's going to stay that number and then you just drop all the other ones out. So if it's 5 or higher, so if it's 5, 6, 7, 8, or 9, remember that means you're going to round up. Unfortunately, since this was 3, that's not going to round up, it's just going to stay 3. So your final answer for this volume is just going to be 58.3. That's all you got to do. All right, let's take a look at a rectangular prism. So you can see it's still the same idea, it's still the same concept, length times width times height. All right, but you're going to divide it by 3. This one has a rectangular, rectangular base. So the length for this one would be that 17. So you're going to plug that 17 in, which means the width is going to be your 4. All right. If you guys notice, if you just look at those two numbers, that's the area of that base right there. All right. And if you multiply it by that height of 10, that would give you the volume for a rectangular prism of those dimensions. But since it's a pyramid, pyramids are going to be a third of the volume of its rectangular prism counterpart. So if you multiply those 3 out, I believe you get 680, but you have to divide that by 3. So when you do that, you're going to get 226.666666, and it just keeps on going. All right, so just like before we were talking about with this problem, you got to round to the 10th place, which is that first bolded number right there. So you got to look at the 100th place, this underlined number right here, to see if you're going to round up or down. All right, since it's a 6, that's 5 or higher. So that means that you would round up. So that 6 would become a 7, and then you can get rid of all the rest to the right. So the volume for this rectangular pyramid would be 226.7. All right, we got a couple of practice problems for you guys. There's 2 square-based pyramids, and there's 2 rectangular-based pyramids. All right, so if you guys have any problems or questions, remember, please reach out to Ms. Coleman or myself. I'm sorry, Ms. Coleman and myself. Reach out to both of us. All right, keep us both in the loop. And we will be more than happy to help you guys. All right, have a good one, everybody, and I'll see you after you're done those problems.